In this video, I'm going to show you how to find one quantity as a percentage of another. Another way of saying that is finding one amount as a percentage of another. So let's focus on this question to start off with. A crisp packet weighing 25 grams contains 7 grams of fat. What percentage is this? So how I've explained this in class is you take the smaller amount and put that over, you take the smaller amount as the numerator and the larger amount as the denominator. So this would actually be 7 over 25. Once you've got 7 over 25, you now can multiply that by 100. And to make your life easier, there's many different ways of doing this. To make your life easier, you can actually make this fraction have the same denominator as the number you are multiplying by. So I can multiply this by 4. So 25 times by 4 is 100, 7 times by 4 is 28. Now since we are dividing by 100 and then multiplying the same number by 100, these two actually cancel out, which gives us the number 28. Therefore our answer is 28%. Question number 2. 45 out of every 300 paper clips produced by a machine are faulty. What percentage is this? So again, we look at creating our fraction. So it would be 45 over 300. This actually means 45 divided by 300. But like I said, to make it easier for yourself, I'm sorry, I need to put the multiplied by 100. To make it easier for yourself, get the denominator to 100 again. That way the two hundreds, the divide by 100 and the times by 100 cancel each other out. So here it would be divided by 3. Therefore 300 divided by 3 is 100, 45 divided by 3 is 15. And then divide by 100, times by 100 cancel each other out to get 15%. Now, before I move on, some of you might be wondering, why are we using fractions to start off with? If you remember from a few lessons back, if we have a fraction, decimal, and percentage, we can actually use we can actually convert from fractions to decimals and decimals to percentages. So if we actually have two amounts, we should actually use the fraction first, do the division, and then work out from the we should actually work out the fraction first, get the decimal answer, and then multiply the decimal answer by 100 in order to get the percentage. So let me give you a very straightforward example. 50 over 100. If you actually did the division, which is 50 divided by 100, you would get an answer of 0.50, which is also the same as 0.5. Now, to get that as a percentage, you would multiply by 100. If we do that, we would get 50%. And that works for any decimal. So for example, I'll give you another one. I'm going to use a simplified version this time, 3 over 4. 3/4, you should know, as a decimal is 0.75. To get that 0.75 as a percentage, you just multiply it by 100, which would give you 75%. And that's the reason why we actually work with the fraction first, get the decimal answer, and then multiply that decimal answer by 100 to get the percentage. So let's move on. What percentage of this line is shaded grey? Use a ruler. So I've actually given you the measurements here. The full length from one end to the other end is 20 centimeters, and the grey shaded area is 17 centimeters. So the fraction would be 17 over 20 multiplied by 100. So again, I can actually use my facts of multiplying this by 5 to get 100 as the denominator. 17 times by 5 would be 85, and therefore these two cancel each other out, and it's going to give me 85%. Question number 4. This should be number 5. Okay. On Monday, 3 of my class of 30 students were late for school. What percentage were on time? So again, same thing applies. 3 over 30 and then multiply by 100. Now, unfortunately, we cannot work with this here to get up to 100 by multiplying it or dividing it. You could do one thing. You could divide it by 3. So let's do that to start off with. If we divide both numerator and denominator by 3, we would get 1 over 10. And then we could multiply, so take that times by 100. And then we could actually multiply that 1 over 10. We could multiply that 1 over 10 by 10 to get 10 over 100, times that by 100, and you would just be left with 10%. Now 10% is not the actual answer. It says what percentage were on time. So if 10% were late, that means the actual percentage that were on time is 90%. Do not get confused by that. So the actual answer is 90%. Now I'm going to show you a different method instead of doing all of this working out. Let's start off with what we had to begin with. So I'll change my pen color to... Okay, so let's look at this alternative method. Oops. We start off with the same thing. We've got 3 over 30 times by 100. Okay, so I know if I use my rules of fractions to take any whole number and make it into a fraction, I could just put a denominator of 1, because how many 1s go into 100? The answer is 100. So that would actually make the whole number 100 a fraction. My rules of fractions, how do I multiply fractions? Well, I multiplied both the numerators and both the denominators. So that would be 3 times by 100, which is 300, and 30 times by 1, which is 30. So now that I've got this as my answer, I can actually simplify this to get my final answer. So I could cancel this down and then find out how many 3's go into 30, and that would actually give me 10, because 3 times by 10 is 30. Now again, my answer cannot be 10% because it's asking, it's saying that 3 out of 30 students were late. What percentage were on time? So it's actually the opposite, 100 minus the 10, which should give me 90%. So that is an alternative method that you could use. Let's go to question number 5. Joey scores 36 out of 40 in a French test. Okay, what percentage is this? So, draw. Okay, so again, I'm going to show you 2 different methods. First one, I could use is the 36 over 40 multiplied by 100. I could actually reduce this to get my denominator as 20 by dividing by 2, which would give me 18 over 20 times by 100. I could then multiply that by 5 to get a denominator of 100. 18 times by 5 would give me 85. Eighteen times by 5 would give me 90, and the 2 divide by 100 and multiply by 100 cancel each other out, which would give me an answer of 90%. Now, alternative method. I'm going to take the original fraction or the original equation across, and I'm going to work on it in a slightly different way. So 36 over 40 times by 100 over 1, which would give me 3,600 divided by 40. Can cancel this down and cancel this down, would just give me 360 divided by 4, and that would get me also 90%. There is also another method. You could simply just do the division here and get the decimal answer and multiply it by 100. But I'm just trying to give you alternative methods. The think question. Okay, so this one, well, it is a think question, so you have to think about it. It says, in year 8, there are 105 boys and 145 girls. What percentage are girls? So the first thing that you need to realize is you don't have the total amount of boys and girls in the class. The first thing that you need to consider is that you don't know the total amount of students in year 8. For that, you'd have to add up the boys and the girls. So the first thing that you actually need to do is add up 105, add 145, which should give you 250 students. That's including both boys and girls. Now you can actually work out the percentage of girls. So 145 over 250 times by 100. Okay, so we could again use the same method that we did before, or you could do something else. So I'm going to actually show you a different method this time. Still very similar, but slightly different. So I'm going to take this 250 and make it into 1000. So I'm going to multiply that by 4. I'm also going to take 145 and multiply that by 4, which gives me an answer of 580. Okay, and then times this by 100. Okay, so if I actually work this out itself, I can actually see that 580 divided by 1000 would give me an answer of 0.58, and when I times that by 100, it should give me an answer of 58%. So the final answer is 58%. This is just another method of doing that. The reason why I did it this way is because, first of all, if I did 145 times by 100 over 1, I would go into large numbers. The second thing is, if I tried to divide this down and get myself to 100, I would probably have to go and divide by 50, which would make this very messy as well. So I used my logic and I thought, okay, I can actually make this into 1000, and dividing by 1000 is almost the same as dividing by 100 when it comes to moving the numbers around, or the decimal point, whichever way you see it best. So that's why I actually multiplied this to make it 580 over 1000, because I know for a fact if I move the numbers from the decimal point, I would still get 0.58, which makes it easier for me to see. So the final answer is 58%. Now, if you have got onto the extension question, it says 5 footballers record the number of total number of goals scored in a season. 5 footballers record If you go into the extension question, it says 5 footballers record the total number of goals scored in a season. You've got 4 players there, the goals that they scored and the goals that they played. Who was the most successful goal scorer? Show your full working. So what you are supposed to do here is find the percentage of each player based on the goals that they scored and the games that they played. So if you were to actually work this out, you would, again, you can use many different methods to do so. You could have You could use any of the methods that I've shown you to do so. I'll just give you the answers for the percentages. I've actually written them down rather than going through the full thing. Okay, so if you had done 8 divided by 25 times by 100, you would have got the answer as 32% for player number 1, 40% for player 2, 25% for player 3, and 56% for player 4. Therefore, player 4 is the... So for this question, I've gone straight to the answers. It's again the same process: 8 over 25 times by 100 for the first player, 14 over 35 multiplied by 100 for the second, 3 over 12 multiplied by 100 for the third, and lastly 14 over 25 multiplied by 100 for the last one. And if you actually work out the percentages, you will find that the last player has got 56%. So the last player scored 56%. You would find that the last player, scored 50% of the time that he played. So therefore, the most successful goal scorer is the last player.